Hey everyone, so welcome, and we're going to talk about literal equations today. So this slide is your note slide, and a literal equation, if you think of like literature, it just has a lot of words, a lot of letters. So a literal equation just is an equation that has more than one variable or letter in it. Okay, so y equals mx plus b. That's a formula that we've been, very familiar with this year. That's an example of a literal equation. This example right here, h equals a times b plus r, is also a literal equation. And this goes through an example of how you would solve that. So for literal equations, they don't just say solve, right? Because solve for what? I've got more than one equation to solve for. So they will always say solve for a, x, b, whatever the variable is that they want you to isolate or get by itself. All right, so we are going to do an example together on the next slide. All right, so here we go. The formula is for a volume of a cone. So it's V equals 1/3, that got chopped off a little, but 1/3 times pi r squared h. So just remember when you're looking at this formula that anytime you have like terms connected, it's always multiplication. So it's 1/3 times pi times r squared times h. Okay. So that's just a good thing to remember, especially when we are going to be doing the reverse to basically undo the equation for whichever variable we're solving for. All right, so now solve the equation for h in terms of v, r, and pi. All right, so many people get confused or thrown off by in terms of. What does that mean? It just means that these variables are also in the equation. All right, so it doesn't really have any huge significance in it. Just don't be thrown off by it. So here, what are we solving again? Oh, we're solving for h. So again, remember, in literal equations, they always tell you which variable to solve for, and that means to isolate it. So it is the only thing on its side of the equal sign. All right. And remember that I've got this equal sign here. This is like the balance beam, right? So if you have like a scale, right, where you've got something on this side, you guys have probably seen scales. I'm probably not drawing it very well. Looks more like a face to me, right? But if you have things on a scale, what's on one side, in this case V, has to be exactly equal to what's on the other side, which in this case is 1/3 pi r squared h. Okay, so we want to focus on h. Okay, let me see, what variable are they asking you solve for? H, right? We've gone over that. What is the phrase in terms of mean in this problem? So again, just that those variables are also there. All right, so I am going to set up a 2-column proof like we've been doing in the Desmos activity, and you'll see more of that. So we have the problem, right? So we have the equation, and I'm just gonna abbreviate. So we have the equation over here, and then we're going to have the reasons. And I'm also going to abbreviate because it is tough. Oops, this is particularly bad job. So the reasons why, okay, or the properties. That looks really bad, but reasons. All right, so equations. Okay. All right. Okay. So we start with V equals 1/3 pi r squared h. All right. So I'm looking at this, and my first one is always a given, right? That's just what they gave us, this equation. So now what do I need to do to actually solve this for h? All right, so I look right here, 1 divided by 3, right? So I know that I have division, that I'm going to need to undo. And I have everything touching each other, right? So we talked about how when those variables or numbers are just right next to each other, nothing's in between. That's always a multiplication, right? So let me just put an X over here for multiplication. So these are the two operations that I'm going to have to undo to solve for H. So let me focus on this division here. Okay, so I've got 1 divided by 3. Let me choose a different color. So I'm going to do the inverse of that. I'm actually going to multiply this by 3. Okay. And again, what you do to one side, right? So we're multiplying by 3 on one side. We've also got to multiply by 3 on the other side, right? So I'm also going to multiply it by 3 here. Okay. So 3 times 1 is 3. Let me actually do that over here on my scrap side. So 3 times 1 is 3 divided by 3. Okay, so 3 divided by 3 just gives me 1. Okay, so here I would have 3v equals, and I've already shown that this right here, that can cancel out and it gives you 1, right? Because 3 divided by 3 is just 1. So I would put a 1, but we're really trying to write this like mathematicians. And if it's a 1, unless that's the only thing there, everything else has been canceled out. If it's in front of any variable or other term, we just don't write it. It's assumed to be an invisible 1 there. Okay, so I'm actually just going to write pi r squared h. And on this side, I'm going to write what I did, right? So I multiplied, and you can write the actual rule, at least in my class, so check with, if you're not in my class, just check that that's still okay. So you can write multiply by 3. If you want to write the, what am I talking about? Like the principle or the, I forget the name of it, but you can say, the property. You can say multiplication property of equality. All right. So either one of those would be a fine, either reason or property. All right. So now I still don't have H by itself. And again, these both are connected to it by multiplication. So I'm going to do the opposite of multiplication, right? Which, let's go back to, let's actually do a new color. All right, so I've got these invisible multiplications here, and the inverse of that is division. Now, it's kind of tricky because I've got both of them here, and if they're both pi and the r squared are both there by multiplication, I can just use that same division to do the inverse. So I'm going to divide by pi r squared. Okay, don't worry about the squared right now. We don't need to do anything with it. We're not solving for r. So that kind of throws off some people sometimes. Okay, so pi r squared. All right, so again, pi divided by pi, anything divided by itself is 1. So if I had pi divided by pi, that would still be, oops, okay, I did it too close to that. But pi divided by pi is still 1. Anything divided by itself, 1, right? Same thing with r squared divided by r squared. I can cancel them out, not because they disappear, but because they turn into 1, all right? So on this left side, I now have 3v divided by pi r squared. So I'm just rewriting it, right? Because there's so many variables, I'm not able to simplify it, right? It's not like 3 divided by 1. It's these variables. So I have to keep those variables in there. And then on this side, right, I have 1, right? This canceled out to 1. This canceled out to 1. So I really have 1h. But again, I don't put that 1. It's assumed that it's there. Okay. So I'm going to write division. You can put division property of equality here, but I'm going to just put divide by pi r squared. Okay, Now, see how H is alone? It is by itself. It is isolated. That is considering solving for H. All right, so good luck. Look over your notes, do the Desmos, and that is it for this lesson.